Hi, I'm David Goldberg, engineering faculty member at the University of Illinois. And I'd like to talk a little bit in this short video about engineers, models, and thought. What we're really exploring is how is it that engineers think about problem solving? What kinds of tools do they use? And I'd like to argue that engineers think with models. Now, engineers use many different types of models. The simplest kinds of models are physical models of some real systems. So we'll actually build a prototype. But we also use visual models. We'll use drawings, or we'll use mental models, or more recently we've tended to use analytical models, computational models that represent some facet of a system. And so in this sense, engineers are fairly eclectic in their model usage. You might say that engineers have a Will Rogers theory of model usage. That is, they've never met a model that they didn't like. Now, another point to make is that for engineers, models aren't the thing. Say, comparing engineers to scientists and mathematicians and scientists are in the model-making business. But engineers think of models as tools for thinking about and solving some problems. So, for engineering, model usage is instrumental to the problem-solving process. It's not something that they do for itself. And so, from that perspective, when scientists and mathematicians build models as an end to itself, engineers are not usually in that business. And from an engineer's perspective, scientists and mathematicians are mainly useful as tool makers to help engineers solve problems. Now, of course, engineers use math and science, as well as many other types of tools. But again, they're instruments or tools to help make useful artifacts out in the world. Now, when we think about things this way, there's an important point to make about the economics of model usage. That is, engineers aren't doing this for fun. They're doing it to make an artifact better in the world. And so we need to explicitly consider the economics of model building and usage. And so one way to do that is to consider that models live on a plane of modeling error. That is, that there might be some discrepancy between our model and the actual thing that we're building out in the world itself. And associated with a given level of error, there might be a cost of model building. Now, this is an interesting way to think about this, because it'll often be the case that an engineer or an inventor will use a model of relatively high error and relatively low cost, whereas, of course, scientists and mathematicians are often the model building arena, and so they're very interested in more and more accurate models in some sense, and less concerned with using models. So this perspective of being a user versus a maker is an important one to make. And when we think about it, it points out an important distinction as to how an engineer will use a model. And but when we think about the types of models that exist in the world, and we think about the spectrum and how it lines up, we can think of there being fairly low cost and relatively high error models, and fairly high cost and low error models. And if we kind of line them up, they go from unarticulated wisdom, or what some have called tacit knowledge, on the one hand, to things like Newton's laws and Maxwell's equations of motion that tell us quite accurately how some natural system is going to behave. And in the middle is a modeling middle, where we have qualitative models or dimensional models, facet-wise models that aren't exactly accurate, but not exactly tacit or intuitionistic. Now, when we think about this idea of using models, and we think about it economically, we have a vast array of models. So we can use our engineering judgment, or we can use Newton's laws. Which should we use? And so from an engineer's point of view, we need to think about the economics of model usage. And so from the standpoint of being economic in our model usage, we'll consider using a particular model and improving it. And improving that model, going to a model of lesser error, will imply that we have a greater cost, a change in cost, a delta C. But in addition, we expect that there'll be some benefit to the design of the object that we're considering. So there we'll think about the improvement in error giving us, say, a benefit or a delta B. And so an engineer will be economic in his or her model using when that delta C is less than or equal to the increased benefit that we expect to get in model building. Now, this is a very economic point of view. We're taking a marginal utility approach to model building. And of course, that relates to the great economist Alfred Marshall and the whole marginal analysis of economic systems. But it's less often thought that our model building and using takes on this kind of economic form that we've been talking about. But it's absolutely essential for engineers to be in this business of economic model building and usage. After all, engineers are not about building better and better models so much as they are in the business of using models to create better technological artifacts. And so this approach of thinking about modeling being economic in some sense is a distinction between what it means to be an engineer on the one hand and a scientist or a mathematician on the other.